Okay, we are going to look at a lesson on the friction on an inclined plane, and we will demonstrate this application of friction on an object which is actually moving on an inclined plane. And so we notice that this object orientation, this is the object moving on inclined plane. We have mass 1 and we have mass 2. Mass 1 is 16 kg and mass 2 is 25 kg. So let's read the question and understand and be able to apply to solve concepts in order for us to solve this question. A counterweight is used to slide an object with a mass of 16 kg up an inclined plane. Okay? The counterweight has a mass of 25 kg and is suspended with a massless pulley. The coefficient of friction on the plane is 0.19. What is the acceleration of the 16 kg object? So this is actually the question. And so we have said that this is the orientation of the objects. And so we can identify the forces that are at play by fully understanding the question. So that there is no friction on the pulley and that these cannot extend. So therefore, there is a tension here. This object will be moving down and there is the tension, the same tension, because these cannot extend, meaning that the tension is equal to tension, and the tension is a force on a rope or on a string. And so the other forces that we have is that this object mass 1 has a normal force, which is similar to the opposing force if we drew a component here. And if this is the weight of this object mass 1, it means that we can draw a triangle, and this is the same angle, which is 20 degrees. This angle here, meaning that this side, which is the same as the normal force, it will be mass 1 multiplied by g cos theta, because it is adjacent to this plane. Similarly, this one, it will be mass 1 multiplied by acceleration due to gravity sine theta. Sine theta meaning this angle 20 degrees. And this is parallel to this force here. So it is the same one, which is m1 g sine 20 degrees, which is the same, so sine theta. And so these we have identified. So in other words, we are saying the normal force, which is perpendicular to the plane of the incline, is equal to mg1 m1g cos theta. Okay. And so from the basic understanding of acceleration, we know that acceleration is equal to force is equal to mass 1 multiplied by acceleration for this object on an incline, on an inclined plane. So for this object, this is its acceleration. And therefore, the forces which we have is the tension, which is greater because this object is moving up. So we have to subtract the opposing force. So we are told that there is friction here. Friction is opposing the motion, and therefore it will be on the opposite. So we have to subtract it because it's moving on a different direction. It's against the tension force. Also, we have another force, which is m1 g sine theta. also in the opposite direction from the tension or from the movement of the object. And therefore, we can say is equal to mass 1 multiplied by acceleration. So we can now substitute the tension minus. We know that our friction is given by friction, kinetic friction for an object which is moving is given by a coefficient of kinetic friction multiplied by the normal force, which gives us friction is equal to coefficient of kinetic friction multiplied by the normal force. And the normal force we said is M1 G cos theta. And so we are going to substitute here for where there is friction, we're going to have coefficient of kinetic friction multiplied by the normal force minus M1 G sin theta, which is equal to mass 1 multiplied by acceleration. And we are aware that T is equal to coefficient of kinetic friction, and the normal force, which we have already defined there, is mass 1 multiplied by the acceleration due to gravity cos theta minus mass 1 multiplied by acceleration gravity sin theta is equal to mass 1 multiplied by acceleration. And so we have come up with the actually one equation here. We have come up with the one equation. And so we can make T the subject of the formula. If we made T the subject of the formula, from here, it means that you're going to have mass 1 times acceleration. And this, which was the negative beside mu, meaning coefficient of kinetic friction multiplied by mass 1 G cos theta, it will be positive when it comes this side. So we're going to have coefficient of kinetic friction mass 1 G cos theta, and then you will take the other thing to our side also to be plus M1 G sin theta. So this is our equation number 1, showing that this is the tension. And so the other equation which we have is based on also the other object mass 2. We know that this object here is moving going downwards, meaning that M2G, or the weight of this object, is greater than the tension. And therefore, we are going to say as well, to get the resultant, we are going to say M2G minus the tension, because it's going down, is equal to mass 2 multiplied by acceleration. So we can get also the tension, make T the subject of the formula. So it will be T is equal to M2G minus M2A mass 2 multiplied by this. We have merely taken the tension on the other side. And this gives us the equation number 2. And remember, we said tension is equal to the tension, because this rope does not extend. So the movement of mass 1 is the same as the movement of mass 2, meaning the acceleration for mass 1 is the same as the acceleration for mass 2. mass 2, mass 1, and mass 2 have the same acceleration. Well, and then we can equate these two equations now. We can say mass 1 times acceleration plus coefficient of kinetic friction, mass 1 multiplied by g, and cos theta plus m1 g sine theta should be equal to mg m2 g minus m2 a. Okay, so this is the equation that you have merely equated equation 1 and equation 2. So this is actually equation 1, and this is equation 2, because these are the same, they are tensions. And meaning that we can correct the right terms together. Mass 1 times acceleration will bring the other one, mass 2 multiplied by acceleration should be equal to m2 g minus coefficient of kinetic friction m1 g cos theta, and then minus m1 g sine theta. So this is what it gives us, and therefore we can factor out the acceleration, which is common, and therefore inside we are going to have mass 1 plus mass 2, which is equal to m2g minus coefficient of kinetic friction multiplied by mass 1 g cos theta minus m1 g sine theta. So we can make acceleration the subject of the formula, meaning that we are going to say acceleration is equal to the whole of this equation actually. M2 M2g, which is the same equation ordinary, M2g2 minus coefficient of kinetic friction, M1g cos theta, M1g cos theta, and then you have minus M1g sin theta, M1g sin theta, and then divided by M1 plus M2, which we factored out. And therefore now we can merely substitute what is supposed to, what is mass 2? Mass 2 is actually 25 multiplied by 9.8 minus 0.19. This is the coefficient of kinetic friction multiplied by mass 1 is actually 16. Multiplied by 9.8 acceleration due to gravity cos 20 degrees minus mass 1 is actually 16 multiplied by 9.8 multiplied by sine 20 degrees. Then we divide the whole of this. Oh, sorry. So I can cancel. Then, okay. Then we can divide everything here. Divided by mass 1 is actually 16 plus mass 2, which is 25. Oh, 25, which is 25. 25 kg. 25. And what we find is that acceleration is equal to 3.9 meters per square second. So this is how you can calculate actually acceleration on an inclined plane where there is friction. Thank you.